Like the graphs.
They are graphs, yes. So what is the root word of conic? Cone, right? So it is a section or a cross section, meaning I'm cutting like across a cone, alright? And we have 4 different types, alright? The first one, or it's the last one we're going to talk about, but this one is a hyperbola, so it looks like 2 parabolas that are facing opposite directions of each other, alright? Then as I change my angle, notice that if I'm at a 45-degree angle, we just get a parabola, which is what we'll be talking about today. Then if I keep going, notice that we get an ellipse. And if I cut it exactly straight across, sometimes this doesn't look very nice, we will get a circle. So your 4 conic types are circles, parabolas, ellipses, and hyperbolas. All right, we will talk about all of them. We will spend the least amount of time on circles because you should have seen circles in geometry. Also, circles are just a particular type of ellipse. So we're not going to spend a ton of time on those, but we will look at each of the other ones. Now, I will say this unit is very formula heavy, which is why you have your formula sheet in front of you. Because the goal is for you to figure out, 1, how to graph these different types of equations, 2, how to find equations and like do other things with them. We don't want you to worry about memorizing all of the formulas, because again, there's a lot of them. But you do have to understand how to use them, even if they're given to you. Yes? So, with our parabolas, we have looked at parabolas before when we talked about graphing our quadratics. However, we are going to more look at them in terms of like a geometry, kind of like shape, distance type view now instead. So, a parabola is all the points that are equal distance from both a point, which is called the focus, and a line, which is called the directrix. So what that looks like so if I have some point and I have some line, okay, I want to find all of the points that are equal distance or the same distance from that point and that line. So notice that the easiest one to find is going to be the one that is exactly like halfway in between those two things. Yes? If it's halfway, then it's equal distance to both of those. Do we agree? But notice that like as I go to the left, all right, in order for us to stay the same distance from the line and the point, we would also have to go up some in order for the distance to stay the same. Same thing if I go to the right, it will also. So what ends up happening, maybe, is we get a parabola-like shape. Like that. Now, if my focus is below my directrix, then my parabola will point down. And we've looked at up and down parabolas before, but now we can also get left and right parabolas. Because same thing, if I look at the point exactly halfway in between, okay, but this time to the right in order for it to stay equal distance. And same thing as I go down. Yes? And again, I'm not going to ask you to like construct these and find like the distances or anything like that, but I do want you to know like that's where we get parabolas from, is by finding distances between lines and points. Alright. So on your paper you have this equation, so don't feel like you need to write it down. Alright, the only difference is on your paper it has a C instead of a P. They mean the same thing. That's just your book uses a P versus this handout uses a C value. But they mean the same thing. Alright. The biggest thing to notice is that our vertex, okay, which is that point that's exactly halfway in between, okay, our directrix and our focus is your vertex, and it's kind of all centered around that. And that's given by H, comma, K. Our H is always going to be with our X, and our K is always going to be with our Y. If our vertex happens to be at 0, 0, then notice basically our H and our K go away because they're 0. Yes? Okay. On your paper, you have something that looks similar to this. Okay, so notice that if I have an up and down parabola, it's going to be the x minus h squared. So my x is what's going to be squared. If my c value is positive, then it's going to point up. If my c value is negative, it's going to point down. Okay, notice that that c value is going to be the distance from your vertex to your directrix, as well as your vertex to your focus. So C is always the distance between those two things, which is why then to find your focus or your directrix, we add or subtract C if you have your vertex. Your left and right parabolas are very similar. The only difference now is when C is positive, it's going to point right. When C is negative, it will point left. That C value is still the distance, though, from your vertex to your directrix and your focus. But notice now, I'm adding and subtracting it from my x values instead of with our up and down, we added and subtracted that from our y value. Yes? Also notice that on our left and right one, your y is what's going to be being squared. What questions do we have so far? Alright, you ready to use all those formulas? So this says, find the standard equation of the parabola with the vertex at the origin and a focus at 2, 0. So the first helpful hint that I'm going to tell you is that for any of these conic section problems, if they do not give you a graph, then you want to do at least a rough sketch. Okay, it doesn't have to be the most accurate sketch in the entire world, but we do want to give some kind of sketch so we can kind of figure some stuff out. So what's the first thing that they tell us? Cool. What's the second thing that they tell us? Okay, in which direction is that from my origin? Left, right, up, or down? It's to the right. 2. Yes? And looking at our picture, where does our focus always have to lie in regards to our parabola? Does our parabola ever cross the focus? No. Is it outside of it?
The focus goes down the middle.
It does, but specifically down the middle. Where? It typically go down the middle on the opposite side as well. So where is it in regards to our parabola? Inside of it. Do we all see that? Yes? Which is why it's helpful for us to draw a picture here, because now we know what direction does our parabola have to open. To the right. Because our focus has to be inside of it. Are we all okay with that? We all see how we kind of figured that out. And that's helpful because now we know, okay, if I have a left and right parabola, which one of our variables has to be the one that is squared? The y value has to be squared. Okay? So that tells us that we're going to use that one. But we already know two of those values. It tells us that we're centered at the origin. So what are h and k? 0. Well, that's nice. Now, it does ask us to find the equation. So remember, with any equation from a graph, I want x's and y's, okay? Like that's how I get a graph. It's by having x's and y's in my equation. So those are going to stick. However, we do have an extra variable right now, which is what? C. So, in order for us to have a finished equation, we do have to find the value of C. But what did we say our C value is?
The distance between the focus and origin.
Okay. Well, not necessarily the origin. The vertex. Now, it happens to be the origin here, but it's not always the origin. It's the distance between your focus and your vertex. What is that distance in this case?
2.
2. Now, in this case, we can just kind of count it, right? Because it's pretty straightforward. However, what could we use if it wasn't as straightforward? To find the distance between 2 points.
The distance formula?
What is our distance formula?
X equals the square root of...
It's not x.
Or D, actually. The square root of the second x value minus the first x value plus the second y value minus the first y value.
Not quite. You're missing something.
Parentheses. Or actually, they need to be squared as well.
Yes. So it's the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. Also remember that we get that from our Pythagorean identity. D squared equals basically x squared plus y squared, or the distance of both of those sides. But as I said, in this case we can just see that it's 2, so we're going to plug that in for C. And what do we get? What do we get? Y squared equals 8x. That's our final answer. That's the formula or the equation that would give us that graph. What questions do we have there? Just no need to. Questions? No? Okay. Alright. Next up. This time they give us an equation. We don't have to make our equation. It says to find the focus of a parabola given by y equals negative 1/2 x squared minus x plus 1/2. So on our sheets, what is the formula for our focus when I have stuff that has an x squared in it?
H with then K plus C.
Do we all see that? I need more yeses or nos.
Yeah,
Do we all see where we are getting that formula from? Because like I said, it does not help us to have the formulas if we don't know which ones to use and how to use them. So do we all see in our equation I have an x squared, which means that I'm using my x squared stuff. So I'm looking at my focus formula for my x squared stuff, and we have h comma k plus c. Yes? Alright. Now, what are the three things then we need to know to be able to find our focus? What are the three things that are in that formula? H, K, and C. Yes? Now, notice that in our formula where it says standard form, H, K, and C are pretty easily determinable. Yes? But what's the problem between the standard form that's on our formula sheet and the equation that they give us? Do they look the same? No. Okay? So remember that this is general form. So that is the y equals ax squared plus bx plus c. Alright, which doesn't tell us a whole lot of information in order to be able to find what it's asking us to find. Yes? So what would it be helpful to do? Yeah, put it in standard form instead. Agreed? Alright, now, hopefully some of us at least remember a little bit that the way that we do that is by completing the square.
You just gave me a lot of flashbacks.
So, we are going to complete the square. If we're not good at completing the square, we're going to get really good at completing the square because we do have to complete the square with all four of our conic sections. So we're going to be completing the square a lot in this chapter. Yes? So remember that our first step in completing the square is that our a value has to equal 1. And we can do that one of two ways. One, we can factor out that a value. Okay? Or two, we can multiply by something strategically, or pick something that's a good number to multiply by that'll make our a value 1. Yes? So like in this case, what could I multiply my equation by to make that a 1 in front of my x squared instead of a negative 1/2? Negative 2. But remember that I do have to multiply that to both sides and to everything in my equations. So we get that. Are we all okay with how I got there? And why we chose to get there? Because remember that our completing the square steps don't work if that leading value is not 1. So then our next step is going to be to add b divided by 2 quantity squared. So what's our b value? 2. What is 2 divided by 2? 1. And squared is 1. Also 1. So we're going to add that next to our x. Yes. But am I allowed to just add something because I feel like it? No. So within that, we also have to balance our equation. So what could we do to balance that? If I added 1, what else can I do?
Subtract 1.
Sure. Alright, if I subtract 1 from the outside, now technically, what have we added between the two of those? 0, which means that it's balanced. I haven't actually affected it. I've just kind of rearranged what it looks like. Are we all with me? Would there have been another way to balance that instead? If I add 1 to one side, I can also
Add 1 to the
add
other
1
side.
to the other side. Either way is fine. You'll get the same answer doing it either way. whichever one makes you feel better. Then our last step is to factor. Now, notice that in your equation, right, we have stuff squared. It's a perfect square. So the whole point of completing the square is to make a perfect square. So when I factor this, we should get the same factor, okay, twice. So what multiplies together to give me 1, that adds together to give me 2.
1.
1 and
1 and 1.
1. So our two factors would be x plus 1 times x plus 1, which is why we get x plus 1 squared. Which is what we wanted, because now that's looking pretty much like closer to what we want in our standard form. Yes? Alright. But now, looking at the equation we have here, what's the difference between that equation and the standard form that's on our formula sheet?
Still the value on the outside of the x squared.
Yeah, so notice that here we have a minus 2 next to our x squared. On our standard form formula, is there a number or variable next to your x squared? No. So that means that we need to move it to the other side. So we can do that by adding 2 to both sides. Yes? And then lastly, in our standard form equation, is there a number in front of your y value? Kind of, right? It's separated by what? Parentheses. So right now, do we have a parentheses?
No.
No. So to get those parentheses, what would I do? Factor out a negative 2. So we get y minus 1. So now, this is our standard form equation. What questions do we have on all the steps that we did to get to the standard form equation? Like which one are we trying to make it into? X squared. My side. Alright. So now that we have that formula, what should we be able to identify?
The vertex.
Yes, and our vertex gives us what?
H and K.
Okay, and then what else should we be able to identify?
C.
Yes. Front of the room, do we agree?
Yes.
Okay. So what is our H value? Negative 1. So for both H and K, it's going to be the opposite sign of what's in there. Alright, which means that K is what? 1. Now be careful. What is C? So the number that's in front of our Y is what?
Negative 2.
Well, yes. In our formula, what's in front of the Y?
4C.
4C. So that 4C equals negative 2, right? So C isn't negative 2. In order to find your C value, you have to divide by 4. So what do we get? Negative 1/2. So now, what can we do? Plug it all in, right? So I have negative 1, comma, 1 plus a negative 1/2. So we get negative 1, comma, 1/2. And Algarians. What questions do we have there? we all see how we found our H, K, and C? Like where we're getting them from? Alright, let's look at another example. So this one says, find the standard form of the equation of the parabola with the vertex 2, 1 and the focus 2, 4. So again, what do we say it's going to be helpful to do? Make a graph. So where is our vertex? So 2, 1. And where is our focus? Which is going to be in what direction? So this time we know that our parabola is going to be opening upwards. Yes? So if it's opening up, which one of our variables is going to be squared? The x. Okay? So that means that we're using the x minus h quantity squared equals 4c times y minus a. Now, do we know what h and k are? Yeah, they just give it to us this time, so that's nice. So I have x minus 2 quantity squared equals 4c times y minus 1. Yes? And again, remind me, what is our c value?
3.
No, like in general, what is our c value?
Distance between the focus and vertex.
Okay. So in this case, to go from 2, 1 up to 2, 4, we have to go 3 units. So we end up with x minus 2 quantity squared equals 12 times y minus 1. Do we all see how we found those values? Why we plugged stuff in the way we did? And how we chose which equation we were going to use to begin with? Yes? Okay. Alright. So now we're going to practice graphing it. So, remember that we said that our parabola is kind of centered around our vertex, yes? So it's going to be helpful to find where our vertex and plot that first. So where is our vertex?
4, 5.
Is that in the right form?
No, it's
Yeah. So what might we do to change it to our standard form? So this is vertex form that we have when we had quadratics. But what do we need to do to make this form match our standard form on our equation?
subtract 5 on both sides.
Okay. What else? What do I need to do to get rid of the negative 3? Which is the same thing as multiplying by negative 1/3. So now we're in standard form. And so, yes, our vertex is at 4, 5. Which direction are we opening?
Upward.
Correct? You sure?
Downward.
What would our C value here be? So 4c equals negative 1/3. So c equals
Negative 1/12.
So if that is negative, what does that mean we are pointing? Down. So that would be our graph. So basically the two things that I'm mostly checking for are, one, is your vertex in the right spot? And then two, are you opening in the correct direction? The last thing that I'm checking for is, did you graph the correct conic section? So like as we start getting farther along and we learn how to graph our other things, right? If I give you a parabola equation, you need to graph a parabola, not an ellipse. Does that make sense? So shape, vertex, and which way are you opening are the three things that I'm checking. So it does not have to be the prettiest or the most accurate graph in the world, as long as you're doing those three things correctly. What questions do we have there? Alright, I think we got one last one. Alright, so this one tells us to graph again. Which one of our variables is squared this time? The y, okay? Which tells us we're going to be opening what way? Left or right? We don't know which one yet because we can't really see. And then also, are we in standard form right now? No. So we are going to have to, bless you, rewrite this in standard form. So we want to get our y squared over to be with the other y. Okay. So is my a value 1 then? In front of the y. Because this time I'm completing the square with the y because it's what's being squared. Are we all with me? Alright, so what's our b value this time? 4. So b divided by 2 gives us 2. Squared gives us 4. So I have to add 4, which means that we also have to subtract a 4. Now again, I can factor from here. So, what multiplies together to give us 4? That adds together to give us 4. 2 and 2. It should be the same thing, because we want it to be a perfect square. And then over here, we will have a plus 6. Are we all okay with how we got up to there? Yeah? So then remember that our last step is we don't want stuff with our y's this time. So we do need to move our 6 over. And we need the number value to be in front of our x. So we do have to factor out a 2. So where is our vertex this time?
3, negative 2.
And which way are we going to open?
To the right.
To the right, because it's positive. Do we all see that it's positive 2? So that means that we're going to be going to the right. And that would be my graph. Now, it doesn't ask us here, but we did talk about it. So we said that our vertex is at 3, negative 2. How would I find my focus in our directrix if it asked us to find those?
We set 4c equal to the 2.
So c equals 1/2. So to find our focus, okay, be careful, because which one do we add our c value to this time? If my y is what's being squared this time. The h. So I would get 3.5, comma, negative 2. Yes? And then if it asked us for a directrix, okay, what would that be?
X equals H minus C.
Which would be, so 3 minus 1/2, which would be 2.5. Agreed? We're all okay with that? So again, if we wanted to graph those, we could. We're at, what, 3.5, so here, and 2.5 there. There you go.